Now a little about heating, ventilation and cooling system. From the beginning, all the buildings were equipped with the same heat pumps to provide the heating, ventilation and cooling. It was air heat pump with the cooling power about 3 kilowatts and the heating power about 4 kilowatts. And interesting is that all the devices can provide also the airflow from the outside to inside. It means that we can provide fresh air, and this amount of this air can be controlled. We can use this ventilation in the 3 different regimes. For the heating, we set about 20 or 22 degrees Celsius during the winter, and during the summer we have made measurements with the cooling, and the temperature was set to 23 degrees Celsius. In the next year, another type of the heat pump was installed in one of the building. It was air-water heat pump with the thermal storage, water storage, and the low temperature convectors. In another building, for the reference, electrical heater was installed, and the measurements of the real energy efficiency in the building with the same calculated energy consumption with the use of different types of heating. We compared the data of heating with the electrical heater, with the air heat pump, and with the air-water heat pump. And the next year, third type of the heating and cooling system was installed in one of the buildings. It was air-water heat pump with similar thermal water storage, but as a heat exchanger, capillary heat exchanger was used, and this type of heat exchanger is placed near the ceiling. Later, we added some phase change materials to buildings, and made experiments with thermal energy storage. You can see on the video the air-water heat pump system with thermal water storage and with the low temperature convector. As you can see, we have 3 convectors here, meaning that we have a large area of the heat exchanger, and it means that we can do the same with the lower energy of the water, of the heating liquid. In this building you can see this capillary heat exchanger on the ceiling, meaning also that we can use the liquid, the water, with the lower temperature and to provide the same heating amount. And so we have this testing ground with possibilities to measure different physical parameters like temperature, humidity, energy consumption, solar radiation, airflows, and so on. And we can measure things like the effect of the phase change materials on the energy consumption, on the thermal comfort conditions, or for example we can measure the efficiency of some kind of energy storage materials, energy storage systems and methods, and we can measure the real energy consumption, the real energy efficiency of the system who maybe are tested only under the laboratory conditions, and we have the possibility to do the measurements under the real conditions, in situ conditions.